Okay, guys, welcome back. This is four-player chess. This is written in Java right now, and I moved it to C# using the XNA framework. I'll show you in probably the next video. So far, if you haven't seen my first video, I went through a little bit of the code, a little bit of my class files, and I'm looking at the actual program running right now. So I just moved my white pawn up 2 spaces. There's some code in there which I'll show you. I can't move it up 2 spaces again because that's not how chess works. So if I tried to move e4 to e6, that's 5. e6, that would be 2 spaces, and you can't do that in chess. So if I try to do that, there's one of my error codes. So before I talked about my check move function, and if I don't enter a valid move, it'll not return the OK string. It'll return an error code or an error message. So you can see invalid pawn move, enter another move. So I can go e4/e5, and that works fine, and you can see my piece moved up 1 space. Show you another error. Let's see. E5 goes to F5. So if I try to move sideways, again, if you know anything about chess, obviously you can't move a pawn sideways like that. So you get another error message, invalid pawn move. If I try to move to one of these invalid spaces I was talking about earlier, so won't really be able to show that right now. I'll do it later. It'll be hard because I can't move my pawns anywhere that makes sense. Let's stop this real quick and I'll show it because I want to. Why not? So if you saw, I can't move one of my white pawns to a place where it could move to an invalid spot, but I'll make it do it. Just bear with me for a second. I don't like to plan these videos out. I just like to do stuff randomly. So that's a pawn. This is the player. I want it to be a white player piece. Run this again. Save all that. So as you can see, I put a white pawn right here where it shouldn't be, but whatever. It's not a capital W. That might mess something up. Let me fix that. Capital W I need here. Is my caps lock on? No. Okay, so again, I've got this white piece here. White pieces are allowed to move up. Again, if you're familiar with chess rules, white can only move up, black can only move down for the pawns. Silver can only move to the right, gold can only move to the left. So I have a white pawn here, whites can only move up. So if I try to move that white pawn up 1, let's see, B11 to B12, cannot move into an invalid board spot. So that's why I have, if you recall, let's take a look right here at my board piece class. I've got this boolean valid. If it's false, you can't move a piece there. So even though white pieces can technically move up, you can't move a piece into an invalid board spot. So these spots are invalid here, same on all these corners. So I had to add some logic in there. And obviously you've seen my pawn logic, so I can only move 1 or 2 spaces depending on standard chess rules. They can also move diagonally to capture a piece. I've done that. Let's see, one more thing, one more error. So if I choose some random thing, h7, h6 to h7, there isn't a piece on h6. So I'll get an error code that says no piece at this position, enter another move. So I've handled most of my standard errors as you can see. So looking back at the code here, looking at my move validation. So the first thing I check when I check a move is whether or not it's an actual spot on the board. So if it's greater than A through N, so if you choose Q, it'll say that's not a valid column. Try again. Same thing with my rows. It's only 1 through 14, so if I choose 15 or 16 or 17, I'll get an error message that says it has to be 1 through 14. Nice try. What's this other stuff? This just handles my moves. Before, when it was just a standard 8x8 chessboard, it was really easy because those are all single digits. So I could just do that easily. Now it could be many digits for my user input to say where they want to move their pieces. So I have to handle that a little bit differently than what I originally did. No piece. So again, if you look at my board piece, there's an occupied, I think. Let's take a look at that. Board piece, there's an occupied. So that says basically whether or not there is a chess piece on that board piece. So I can use that for this, if to determine if there is a piece on that area. So if all of that passes and the user has inputted a valid spot to start with and to move to, I have to check if that actual piece is a valid move. So for instance, let's just look at my board again. So for instance, if I selected E2 to E9, E2 is a valid starting position. It's a valid spot on the board. It exists on the board. There's a piece at E2, so far so good. And E8 is another valid spot on the board to move. So the next thing I check is I'll pass that move on to the next step,